All right, well, hello and happy Friday. And I hope you guys have had a good first 2 weeks so far. Um, and yeah, well, I don't know, maybe I should just check in, take a moment, check in with you guys and ask how are you guys doing? First couple weeks. Okay, I got two thumbs up here. Three, four, okay. Out of so 10% of you are doing okay. Oh, okay, six people now. So, oh, stressed. Okay, could be better. Yeah, okay. And then someone wrote, good, haven't fallen behind yet. Okay, well, then okay. All right. Well, I hope, and I mean, I don't know, these are just empty words coming, but I do honestly hope things are okay. And if things can be better, I do hope things do get better. And just want to make sure to encourage you to um, be nice to yourself. And if you need to take time off, take time off. Of course, there are consequences to taking time off, and maybe that means you don't finish your homework or something like that, um, and that that might come with its own set of consequences. But always evaluate your spot and always kind of figure out what you have and anything. Oh, someone's asking how am I doing? I'm doing just fine. I think um, it's funny, but I enjoy teaching, and so whenever I'm teaching, I'm always in a good mood generally. Um, but yeah, it's sometimes it's hard to wake up in the morning though. I always feel like I'm tired. So, but yeah. Okay, well let's get into today's material. We're going to talk about environments and scoping rules, and this is kind of um, how R handles the way it searches for variables here. Okay, and I've taken I've got pictures in here, but all of these pictures I have copied from Hadley Wickham's book, Advanced R, which is truly excellent, and this is just a sad kind of a version or summarized version of what what he's written in his textbook. If you have the time to read that book, highly recommend it. Okay, so we've been working with objects, we've been writing some functions now. And so, we have this idea that, values created inside a function are only accessible inside the function and don't interact with things in the global environment and whatnot. But here we'll kind of formalize the rules and state exactly how it works in R. And so, again, all of your objects and that you create and store inside R during some kind of session, these are done in your workspace. And so, sometimes when you quit R, and unless you changed, well, if you change the settings, like I've encouraged you to do so, R won't ask you the question if you want to save your workspace. But if you don't, it might ask you, do you want to save your workspace on exit and things like that? And anyway, that's going to be your global environment. And when you execute a function, um, when you do that, it creates its own separate environment, which we call the local environment. So objects inside that function are accessible only inside that local environment. And objects in that local environment don't appear in the global environment, right? And objects in the local environment will take precedence over objects in the global environment. And so, in particular, I guess the formal term is that we say the global object in the global environment is masked by the object in the local environment. Okay, if they have the same name. Okay, so that means the object name within the function will reference the local object instead of the global one. And so this is what we want to do. Okay, so let's say we create this variable x is equal to is the value the vector C123 is assigned to X, okay? So often we think of this as kind of creating an object called X that contains the value 1, 2, 3, all right? Technically what's going on is that this vector 1, 2, 3, C123 is created in memory, okay? There's a, inside your computer's memory, we create this object with the values 1, 2, 3. And we are binding that object that exists in memory to the name X, okay? We're gonna say, here's this object, and when we wanna access it, we're gonna bind it to the name X, and when I refer to this name X, it's going to point to the value in memory, all right? So in R, these, the variable name X is a reference or a pointer to the vector, okay? X tells the computer where to find this value in memory, and that's what's going on, okay? Maybe a little bit more CSE than we need to get into, okay? So what is this, okay? So here we create a vector 1, 2, 3, we bind it to the name X, and then we take the name X and we bind it to Y, okay? We say Y is this, and then we have Z is 1, 2, 3. Okay, so what's the difference between Y and Z? Okay, so at a practical level, we say, well, they're the same thing, okay? But they're not, okay? These objects reference, these names reference objects in memory, okay? So X and Y are pointing to the same location in memory, right? So you have a location in memory, and we're pointing to this, whereas Z points to another location in your computer's memory that also happens to contain the values 1, 2, 3 as a vector, okay? Z is pointing to another location that does that, okay? All of these kind of memory management issues and stuff like that are handled automatically by R, and you don't have to worry about it, right? I don't know if you've ever taken another CS course, say like in C or C++ or something, and you have to kind of define these variables and stuff like that, and there, memory management is a tougher thing. R handles all of this stuff automatically for us, okay? And so R does something known as copy on modify. So here I'm going to call create X, okay? And then we're going to say Y. Y points to the same object as X, okay? And then what we're going to do is we're going to take the value 4 and assign it to the third value in Y, okay? And I could use single or double square brackets here, it doesn't matter. Okay, so at first the names Y and X are pointed to the same object in memory. But then what we've done is we've changed the third value in Y, okay, to 4. And when R sees this, it creates a copy, okay? So X is still pointing to this thing, and Y now points to a different thing. So it does, R does something known as copy on modify. Okay, so Y now points to a different object where the value, the third value takes on the value 4. Assignment, when we do this thing, when we do assignment, we are binding some name to a value, okay? And scoping is the act of finding the value associated with the name, okay? And so the scope of a variable is the region of the code where this variable is defined. So, so here we've got Y is bound to the name 1, or to the value 1, okay? And then we're going to create a function G, okay? G is, the name G is bound to this function that we create, okay? And the function is a function of X, and what it does is inside the function we take the value 2 and we bind it to the name Y, and we're going to return the value X plus Y. All right, so if I call G on 3, what is this going to return? Is this going to return 4 or is it going to return 5? What do you guys think? Yeah, okay, everybody's saying 5, and indeed it returns 5, okay? Because the name here, Y, masks the name in the global environment. So when it asks, when we say, give me X plus Y, okay, we have the value 3 for X, and we say, okay, well, I want to look for Y, and Y takes on the value 2 inside this function G, And so indeed, it gives us 5. And so because it finds y inside the local environment, it's not going to bother with the value of y in the global environment. Okay, so you guys know that. All right, the R has a bunch of scoping rules, okay? And this is what we call lexical scoping. And that is if it cannot find a value in the current scope, okay, or current environment, it's going to search the higher scope. Now, in general, we want to we want to avoid this, okay? It's not a good idea to reference objects that aren't defined inside a function, okay? And having to rely on our scoping rules can end up leading to a little bit of confusion and frustration when you're trying to debug your thing later, okay? But it's also important to understand them because sometimes you do, when you write code, you're not perfect, and you find that you're referencing things, and this is often there's kind of like a small version of this happening when you knit your documents and you run into errors, right? If you run into when you're knitting your things and you get this thing name, object X not defined or object Y not defined. And I don't know if you encountered this during your first homework assignment. You kind of have like a version of this. It's not this exact lexical scoping thing, but you're running into the problem where R is not able to find the thing. And that's because when you knit, you're basically starting off with this clean, brand new environment. Whereas, when you're working interactively on in the console and in your R Markdown document, you have your current environment that's populated with a bunch of stuff. And so maybe your code is working locally on your computer, but then when you come to knit, it wipes everything out, and it's basically trying to run it in an entirely clean environment, and sometimes it runs into problems. So I think, during the first week, I said, here's some tips. And one of the tips is to wipe out your environment and see if you can run each code chunk. And if you encounter an error there, something's going on there. Okay, someone's asking a question. What if we want to have a global variable, say a constant, that would be referenced in multiple functions? Would there be better practice than declaring a global variable? Well, there's a few things, but you can do this. You can define some global variable, like some constant, and you can just reference them. And as long as you remain consistent in that, like, nothing else uses the exact same name. So make sure this variable that you are defining has a very distinct name. If you name it something like T, okay, then you're asking for trouble, right? If your global variable name is like the letter J, okay, chances are you're gonna run into this. So run into problems where something else wants to use that name. So make sure it's a very distinct name where you don't have to worry about it being used elsewhere. Another way you can do it is you can just, if you need to use this, is when you define your function, you can say, we need a variable K or something, and the default value is this or something. But yeah, and the other thing is you can write a package where you have a certain namespace and things like that, but maybe beyond the scope of what we want to get to. Okay, but anyway, here's an example of lexical scoping. And so here, Y is not defined inside the scope, right? We have function F, and F is going to return the value X and Y, and we don't have Y defined in here. And so when we call F on 3, we say, what is F of 3? Well, X takes the value 3. And then we can't find Y, so we search the higher scope, and we find 1, and this is going to return 4. Okay, we have a question that says, do we need to define everything again in each code chunk? No. And when you're generating an R Markdown document or something, you could just everything you create from your first line of code exists will get created in the global environment. You just have to pretend that you're taking your R Markdown code and giving it to a friend's computer that has no values in their environment. And so any value you use has to be defined somewhere in that document, but you don't have to redefine it in every code chunk. Each code chunk relies on everything previous to it, okay? Okay. So I think we understand this, right? F of 3 will return the value 4. Let me go ahead and give you your first view quiz answer. Today's first view quiz answer is B, B as in bear, B as in bear. Okay, so this is very, very important. All right, variables defined within a scope only exist in that scope and only for that duration of the scope. So if you, as you're running a function, it only exists while that function is running. If variables exist with the same name outside the scope, right? You got variables inside your function, got variables with the same name in the global environment. They are separate, they don't interact, and the variables inside the scope stay inside the scope. They don't interact with the stuff outside the scope. So when you run a function, it's as its own separate environment that only communicates to the outside world via the arguments going in and the object that's being returned, right? So if you say run this command, rm list equals ls, this is how the command we use to delete everything in the environment. If we were to run that inside a function, which, by the way, is a terrible thing to do, you shouldn't do it. It would only delete all of the objects that have been defined inside the function, okay? Now, there is an exception. There's something known as the superassignment operator, which I will mention here, and we'll talk about how it works. But in general, I say never use this thing, okay? Never use the superassignment operator. This one will search the higher scope right away until it reaches the global environment. And it should not be something you use regularly, okay? So I hesitate even introducing this because when I show you this thing, you say, oh, I want to start using that. And the answer is like, no, you should never really use it, okay? You should never really use it. Okay, so here we're going to define X, Y, and Z in the global environment. It's going to, all of those things are going to take on the value 1. Here's a function F. Inside function F, I bind the value name Y to the value 2. And I also create a function G. Inside the function G, Z gets the value 3. And G is going to return the value X plus Y plus Z. And F returns the value G. Returns what G executes, okay, what G will return. So if I run F, what value is it going to return? And after running F, what are the values X, Y, and Z in the global environment? So when I run F, it says Y gets the value 2. And then again, we define the function G, but we don't execute it until we reach this last statement. The last statement says return G. So now I execute G. Okay, and when I execute G, Z gets the value 3, and I say return X plus Y plus Z. So when I say, okay, I need the value X, I search here, I don't find anything. So I search the higher scope, which is going to be inside of F. Inside of F, I don't see anything. So I go to the global environment and I find the value 1. I say I need Y. I search inside here, I don't find Y. I search the higher scope, I find Y is 2. And then so I take that and I say, and I need Z plus Z. And I search here and I find Z is 3. So I get 1 plus 2 plus 3. F is going to return the value 6. Are any of the values in the global environment affected? They are not, okay? So when I ask for this, F is 6, the values in the global environment are still 1, 1, and 1. Okay. So I hope that makes sense. Here are some illustrations and pictures of how an environment works, okay? The environment is the data structure that powers scoping, okay? The job of an environment is basically to bind names to values, all right? And you can think of an environment as a bag of names, okay? And so here I can create a new environment. I can say E is a new environment, and within E, we can say the name A gets the value false, the name B gets the character A, the name C gets the value 2.3, and the name D gets the values vector 1, 2, 3, all right? And so this is the environment, and each of these names are pointing to some object or some value that exists in memory. As with everything, the environments themselves are also objects, okay? And the syntax to work with an environment is similar to working with a list, okay? And you can use the double bracket and the $ operator to get your values. So E $C is this, E double square bracket D is this, okay? But one thing to know is that an environment is kind of like a bag. It's not a list, so there's no order. So you cannot ask, what is the first item, okay? So again, imagine handing somebody your backpack and you say, hey, I need object number 3. What is object number 3, right? Inside a backpack, there's no order, okay? So inside a bag, there's no order. And so you can't, it doesn't make sense to say, I want the first, second, or third object, okay? It's not a list, there's no order there. So you can't use positional indexing for an environment. Okay, you can list off all of the objects with the named objects in an environment. You can do ls, okay? And we often use ls blank, and this will do it for the global environment, but you can say ls of environment E, and this will be, it will give you all of the names, A, B, C, D. You can also say, I need the structure of these things. So you can say ls.structure of the objects inside environment E, and it gives you the structure, gives you more details on all of those names. Again, unlike lists, you cannot use a single square bracket because, removing, setting an object to null does not remove the object. So if I say D gets the value null, okay, it still exists, okay? This D now takes on the null value, okay? D takes on the null value. If you wanted to get rid of a name, you have to use rm. Okay, we're going to say remove name D inside environment E. Okay. Now, probably in general, most cases, we don't really create our own environments. Okay, we don't. Is it possible to have an unnamed object? No, you cannot have an unnamed object inside an environment. The whole point of an environment, because the only way you can refer to objects inside an environment is by name, okay? And so you can't have unnamed objects in an environment, right? But you know, we probably don't often create environments like this. So back here I said, let's make a new environment, new dot environment. You can do it, okay? But we don't really do it very often, okay? But it's kind of a natural consequence of executing functions. When you execute functions, new environments are created all of the time. Okay, so and what happens when you assign null to an object in an environment? That object in the environment, that name, is now associated to the null object, okay? It's associated to the null object. So, so every environment has a parent, which is going to be another environment. And in these diagrams, you got a little blue circle pointing to the parent environment. And the parent environment is used in the lexical scoping. So often it'll be like, here's kind of one environment which is nested inside this environment, and this keeps going, okay? And all of these environments have a parent environment, and it keeps going until we reach the empty environment, the R empty environment. That's the only one that doesn't have a parent. Okay, so generally we work in the global environment. This is kind of your workspace. The parent of the global environment, this is a little strange to think about, is going to be the last package that you loaded using library. So whichever package you most recently loaded, that is going to be the global environment's parent, okay? And eventually all of these things will keep going. You reach the base environment. The base environment is kind of your base package, and that has all of the names inside base R. And then that one's parent is the empty environment. The empty environment has no ancestors. And then if you were to call environment, that's going to be your current environment. Okay, so if you want to know what are all of the environments, you can type search into R. Search will give you kind of the path of all in the environments. All right, so currently we would have the global environment, and the parent of the global environment, at least when you knit a document, will be knitter, and its parent is stats. And then you got graphics, graphic devices, utilities, datasets, methods, auto loads, until you reach base, okay? And, stats will have functions like LM that allow you to kind of do linear models, and base will have kind of the functions that do things like addition and create a list and print and things like that, okay? And so this is kind of the search path. We got the global environment, all of these packages that we loaded, and the base package, which kind of contains just our most basic structures, names, and then the empty environment. And if we load a new library, right, we say library ggplot2, okay, then that gets loaded in, and that becomes kind of our new parent, right? And so every time we load a package, it becomes kind of the new immediate parent of the global environment, okay? And the reason for that is that's how we're going to find, when we search for a name that doesn't exist in the global environment, it's going to go through all of these packages until it finds that name, right? So when you call mean and you say, I want the mean of a vector, you don't have a function mean defined in your global environment, okay? That function mean is defined, I think it's in base, okay? And so it's going to kind of climb through all of these things until it finds the function mean defined in base, okay? Are the environments one-to-one relationships, or can it be hierarchical? So the search path is this linear thing, okay? The search path is this linear thing. Within each environment, you can have a whole bunch of objects defined, but each environment has only just one parent, okay? Most of the time, we're dealing with environments that's going to happen inside using a function, okay? And so we're going to talk about how this works. And again, a function will have four environments associated with it. You've got the enclosing environment, the binding environment, the execution environment, and the calling environment. The enclosing environment is where your function is created. And every function has just one and only one enclosing environment. The other ones, the binding, the calling, and the execution, you might have 0, 1, or even many of those environments associated with a function, okay? Where you have, where you give the function a name, where the name is bound to the function itself, where it exists, that's the binding environment. In general, your enclosing environment and your binding environment are going to be the same, especially if you're just defining functions inside the global environment. There's exceptions to this when you're like writing a package. But well, okay, I'm getting ahead of myself. When you call the function, it creates an execution environment. That's the environment where the variables that are being used in the function are created and stored. And when the function is called, the environment from which it is called is known as the calling environment, okay? Okay, so the enclosing and binding environments. So when you create a function, there's a reference to the environment for where it's made. This is the enclosing environment. This is what is used for lexical scoping. When you name the function, the environment where the name exists is the binding environment. In most scenarios, your enclosing environment and your binding environment is going to be the same, okay? Again, with the exception of when you're like writing packages, you might have exceptions to this, but in general, you're going to like create a function, you're going to assign it a name in your global environment, and your global environment will be the enclosing environment and the binding environment. Okay, so here is a very, 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 very simple example. So in the global environment, we name an object y, and we give it the value 1. Okay, so the value 1 is bound to the name y. We also create a function called f. Okay, f is going to be the binding environment because the name f exists inside the global environment. I'm sorry, what did I say? The global environment is the binding environment of f because f, the name, exists inside the global environment. Okay, this function was created, the contents of the function, that is this part. Okay, so the name here exists in the global environment. That's the binding environment. This function is created inside the global environment. So functions F's enclosing environment is the global environment. And you can ask, what is the environment of F? And it says the environment of F is the global environment. So this is what we have. And function F receives as an argument the value X, okay? It receives the value X. And so whenever F gets called, immediately it creates a variable called X, and it's going to receive whatever name comes into here, or whatever value comes into here. Okay, so in the search path, what we saw that the parent environment of a package varies based on what other packages are loaded, right? So if you think of your global environment, what's the parent of your global environment is the most recently loaded package. And depending on, if I load my packages in one order, and someone else loads packages in a different order, technically that list of in the search path could be different from me and you, right? And so how are we going to do this, right? Let's say we call the function standard deviation, okay? And if you look at the definition of standard deviation, what it does is it just returns the square root of the variance, okay? That's all it's doing, right? We're asking, I need the variance of a thing, and basically, if it's a, give me the variance. If it's a vector, give me the variance of X, okay? Or if it's a factor or something, otherwise try to convert X into a double, okay? And then give me the variance of that. Okay. How do we know that we're going to use the correct variance function, and that, if somebody had loaded some other package that also happens to contain a function named var for the variance, right? Or just somebody was dumb and decided to create a function called var, okay? How do we know it's still gonna work, okay? Well, we have the namespace, right? The namespace says when we reference these names, the variance, we have a specific location, okay? And so the distinction between the enclosing and binding environment is important inside packages, and that way we know the packages are going to work, right? To ensure that packages work the same way, regardless of what other packages are attached to the user, the package requires an internal environment called the namespace in which the package functions are defined, right? And so every function in a package is associated with a pair of environments, basically the package environment and the namespace environment. And that's so, right? So if I'm using R, right, I could create a function called var, and this will be like return hello, right? So this is dumb, right? So normally if I say I want the variance of 9, okay, or not variance of 9, but if I say like X is 1 through 5, okay, and I say I want the variance of X, this is not the variance of X, right? This is my dumb function here. But if I call standard deviation of X, this works. This works, okay? And how does the standard deviation work? Okay, well, inside the standard deviation, we have the namespace, and it says, when we talk about this function variance, okay, don't use your silly function that you've created here, okay? Don't use this function here. Use the real variance function, okay? Use the real variance function, okay? So let me just... Now, if I say variance of X, this works because I don't have, a silly function named here. Okay, and that works by using kind of these packaging environments and the namespace. All right, so you have this double colon operator, and you can use this to access a function directly. So technically, in base R, in the base package, you have the function mean, but there's another package, Mosaic, okay, and they define a function called mean. And if you want to use the mean directly, or the base package directly, we can do that, right? So if here I can create this function here again, and I'm pretty sure variance is defined in base, right? So if I say variance of x here, I get this, but I can do base colon colon variance. Okay, so so variance is defined inside stats, and so here, if I do stats, the variance here, it gives me the correct value. Okay, so you can access the function directly by using the double colon operator. So you can access the objects even if their names are masked by other objects because of the search path. Okay, so again, you can have the namespace is how we find it, and this is controls how we search for, when we look for variance in it, or the standard deviation, and it asks for the variance, it uses the namespace. Okay, let's go back to this concept of the execution environment. And before I get ahead of myself, let me give you your second view quiz answer, which is the letter A. A as an apple. A as an apple. Okay. So the parent of the execution environment is the enclosing environment, and once the function is completed, this execution environment is thrown away. So here's a function h. Okay, inside h, h receives the value and it assigns it to x as soon as it's called. Inside the function h, it takes the value 2 and assigns it to a, and then it returns the value x plus a. Okay, oh, we have a question. Is it similar to how in Python we write np dot something? Kind of, yeah. You can refer to objects within a certain module or library loaded by using kind of its name. Okay, so and then finally we will call h with the value 1 and assign it to y. So this is kind of how the picture runs. Okay, so we call the function with x equal to 1. So h, this is the global environment here. Okay, h is defined inside the global environment. And when h is called, okay, it creates its execution environment. And immediately, because it was called with the value 1, it's going to assign the name x to the value 1 inside h's execution environment. And inside the execution environment of h, we bind the value 2, and we bind the name a to the value 2. A is bound to the value 2. So this is this is the execution environment for h. All right. This when the next thing, it says return the value of x plus a. Okay. So we're going to do x plus a, and we get 3. And the function returns that value. It returns that value, and we are saying take whatever it returns, 3, and assign it to the name y. Okay, so y now gets the value 3 inside the global environment. And this execution environment over here disappears. And that's basically what happens when you call a function. Okay. When you call the function with some argument, it's going to immediately, as soon as it's called, it creates the execution environment and it assigns the values. This value 1, it assigns it to the name x. It runs whatever other code lines are, and they're all inside the execution environment. And then when it's done, that execution environment goes away, and whatever object it returns gets assigned to wherever it is in the global environment. Okay, so when you call a function, it creates the execution environment. It's got the enclosing environment where the function is created and the calling environment. If you created a function in the global environment and called a function in the global environment, then these things are the same. But in some cases, you might call a function from within another function. And in that case, your enclosing environment and your calling environment are going to be different. Okay, so the function's looking for a value. In general, it's going to look for the enclosing environment. R does allow for something called dynamic scoping, where you can say, I want you to search for values inside the calling environment. Okay. All right. So let's just take a look at this. we have x and y, x is 0 and y is 10 in the global environment. Inside the function f, we have x is 2 and y is 100. And we define a function h, and inside h, x gets the value 50, and it's going to return x plus y. And f returns whatever h returns. Okay, so when we call f, what will it return? Okay, so when we call f, we're going to say, okay, assign x to 2, 2 to x, and 100 to y, return h. So we execute h. Inside h, x gets the value 50. So we do x plus y. X gets the value 50. It finds the local value for x, 50. It's searching for y. What is it going to get for y? Is y going to be 100 or is y going to be 10? Well, it's going to be one of those things. Okay, it's going to add those two together. Either one, which you got to figure out which one. So what is f going to return? Is it going to return 60 or 150? Okay, and yes, because h is defined inside of f, when it searches for y, it's going to pull 100. Okay, and so it's going to return 150. Inside f's environment, it's going to find y is 100. It's going to use that, and it's going to return 150. I hope that's okay with you guys. All right, what about this over here? Okay, x is 0, y is 10. G is over here. Okay, we get x is 2, y is 100, and g is going to return h, whatever h returns. That's the last value. Okay, and over here, h is defined in the global environment, and it says x is 3, and return x plus y. Okay, so if I call h, what is h going to return? X gets 3, y gets 10 in the global environment. So when we call h, it's going to return 13. Okay, let's find x is 3, y is 10, it returns 13. When I call g, what will it return? So inside g, we call h, and what is it going to return? Inside g, we have x is 2 and y is 100. So the question is, do we get 102, 103, or 13? Or a warning. No, we're going to get a value. We're not going to get it. So people are saying 103, but the answer is this will also return 13. Okay, why? All right, so we understand why h returns 13. Right? So when we call h, we get 13. Okay, when we call g, we're also going to get 13. Why? Because when we're looking at g, okay, we call g, we assign x as 2 and y as 100, and we're calling h. Okay, when we call h, we get x is 3, h returns x and y. H cannot find the value y, and so where is it going to search? It is going to search its own parent environment. It's always searching its parent environment. The parent environment of h is the global environment, so it's going to search for y, and it's going to find 10. Okay, so it does not matter that I've called h from inside G, okay? H is not defined inside G, okay? Because back here, H was defined inside of F, and so when it couldn't find Y, it searched its parent environment, which was F. Over here, H is defined inside of the global environment, so when it can't find Y, it searches its parent, which is the global environment, okay? It finds X in its own environment. It doesn't find, so it searches its enclosing environment, which is the global environment. All right, and we're going to get 13, not 103. So a lot of you thought it was 103, but that we are calling H from inside of G, but we are not defining H inside of G. So we defined H inside the global environment. So it uses its parent environment 10 there. Okay. This is dynamic scoping. Okay, this is where we're going to get the calling environment. So here we've defined G in the parent global environment. We've defined H in the global environment. Okay, H is defined in the global environment, and here it is going to search whatever environment. In this variable here, we say Y gets the value of the parent frame, which in their case is whichever environment called it. Okay, the calling environment. So if I call H in the global environment, this is dynamic scoping. If I call H in the global environment, we're going to get X, it finds 3, it searches for Y in the global environment because that is where I called H from, okay? And then this will return 13. If I call G, okay, G, it gets X is 2, Y is 100, and it calls H. It calls H from inside of G. So inside there, X gets the value 3, and when it searches for Y, it says Y gets the value of Y from the parent from the calling environment. Here it's going to find 100. And then it's going to add those two together, and it's going to return 103. So H will return 13, G will return 103. So this using the calling environment requires us to use this thing called get, and this specifically says don't use your normal scoping rules, but use the calling environment. This is the dynamic scoping, okay? This can get messy, all right? This can get messy. So we have that, okay? So the normal rules, it's gonna search the environment from where it is defined, okay? We have that. Okay, oh, I've got these slides on super assignment, and I hesitate to even go over them because I don't want you to use super assignment, okay? I don't want you to use it, all right? But it exists, and sometimes you'll read someone else's code, and you're gonna see this operator, this double, like this double arrow, and you go, what is that, right? Because that's always kind of confusing because you don't like, how do I ask for help on this thing? And it's like, so this is the super assignment operator, and basically, please don't use this. I'm showing you guys this thing, but please don't use this, okay? Basically, it just says assign things to the higher scope. So here I've got X, Y, Z in the global environment. Inside of F, we're gonna super assign 3 to Y. This is gonna change the value of Y here, okay? And we're gonna return Y. So when you call F, it returns the value 3, it returns the value Y. And when you say, what is X, Y, and Z, it has changed. The value of Y in the global environment has changed to the number 3, okay? And you go, oh, that doesn't seem so bad. It's bad, because you have no idea, like, there's nothing in here indicating that we're changing, like when you call this, right? Unless you know exactly what's written inside of your function, there's nothing here that says, oh, guess, by the way, I changed all of this other stuff over here for you. Surprise. And that can get confusing when you're trying to troubleshoot what went wrong. Generally, you want to see like an arrow, right? You want to see like, oh, this is where I modified the value 3, right? When you see an arrow, where did it go? Back here. When you see this arrow, you go, oh, this is where I modified the value 3, right? You're often going to be searching for like, how did Y end up with this value? You go, oh, you can just search for these kind of things as you're trying to debug. And you can say, oh, this is where I modified the value 3. But in this line of code, we modified the value 3, but there's nothing here that says, oh, by the way, I'm changing the value 3. It just happens. You need to know that calling F modifies the value of 3. And unless you've memorized every single line of your code, you're probably not going to remember that. And so troubleshooting this is going to be difficult. Okay. And these are like more examples of like super assignment. And I've written all of these comments on basically what's happening. But here I'm defining G inside of F, and I'm using super assignment. And basically it's going to try to assign the value 3 to the name Z, and it searches the higher scope and it says, I can't find Z here. And so it keeps going and it finds Z in the global environment. Z gets the name changed to 3. Same thing with this thing. It searches for Y in the higher environment. And so when you execute F, okay, it's going to return 1 + 2 + 3. It's going to return 6. That's not going to be a surprise. But after running F, all of these Y and Z get changed. So in the global environment, they are now the values 2 and 3. Okay. It gets worse. Okay. So here inside of F, I'm going to assign the value 2 locally, just regular old assignment. We assign the value 2 locally to Y. And then I say super assign 4 to the value Y. So this thing skips this 2 here and it goes immediately and it changes the value in the global environment to 4. Here, it searches for Z. It doesn't find Z here in the F. So it goes and it changes the value of Z in the global environment, okay? So in the global environment, we have 1, we have 4 because of this thing, and we have Z is 3. We're going to return X and Y and Z. It doesn't find X, it searches until it gets 1. For Y, it goes to the higher scope and it finds 2. So Y is 2. Z, it keeps searching and it finds it in the global environment, and it's 3. So F is going to return 1 plus 2 plus 3. It's going to return 6, but the values in the global environment will be 1, 4, and 3. Okay. Oh, last view quiz answer. Thank you for that reminder. Last view quiz answer is C. C as in cat. C as in cat. That's going to be the answer. All right, and someone just took off, and that's fine. We will just, you can look over these things, but basically super assignment, it's a bit of a headache, okay? And read through these examples. Also on Canvas, where did I put it? On Canvas, I put a supplement of our code where there's kind of like more, I put this script here. If I can open it. All right, and so here's a bunch more functions where you can kind of go through and see, you can kind of ask yourself, what will this, what will each of these things output and return, okay? And you can kind of just take the time, and I think I've written a lot of kind of code to explain how this is working, but please take the time to read it and understand it. These supplements. So go over these remaining slides here. Okay, and basically the last few slides basically say, don't use super assignment. Please don't use super assignment. Okay, and there's an example of why. All right, have a great weekend. Monday is a holiday, Dr. Martin Luther King Day, so we will not see you on Monday, but I will see you on Friday, or not Friday, Wednesday. See you on Wednesday. Okay, so see you Wednesday. Have a great weekend. And we'll see you guys later.